ZAS Robotics, Navigational Robot Car-2. Master wireless control, multi-mode interfaces and communication robotics. Robots that can sense. Robots that can move. Robots that can navigate. But what if you could control them from anywhere? What if robots could receive commands, interpret inputs, and respond instantly, wirelessly? Introducing the ZAS Navigational Robot Car-2, where robotics meets wireless intelligence and control. In Car-1, robots learned how to navigate the world on their own. In Car-2, students learn how to communicate with robots in real time, using the same wireless technologies used in modern engineering systems. Car-2 introduces a powerful concept, a complete transmitter-receiver robotic system. A robot, a remote controller, connected through multiple wireless communication layers. The Car-2 system comes fully equipped with everything required to build advanced wireless-controlled robotic systems. The kit includes fully assembled navigational robot car, UK-engineered motor controller board pre-mounted, UK-engineered remote controller board, NRF24L01 Radio module, Bluetooth module, IR remote and IR receiver, MPU 6050 accelerometer for motion-based control, traditional four-way buttons remote operating mode, joystick module for steering input, gesture control interface, 2 Arduino boards, one for car, one for remote, dual OLED displays, car plus remote, 2 18650 battery cases, battery charger, integrated power routing and charging system, no external wiring required. Everything required to build real-world wireless robotic control systems out of the box. Car-2 is designed as a complete communication ecosystem. The remote controller acts as the transmitter. The robot acts as the receiver. Every command is encoded, transmitted, received, and executed, just like in real industrial and robotic systems. This is not just control. This is communication architecture in action. Car-2 demonstration. NRF24L01 Radio control. Using NRF24L01 radio communication, students build low-latency, high-reliability control systems, ideal for robotics applications requiring precision and speed. Voice-controlled. Bluetooth enables intuitive wireless control, connecting robots to external devices and user interfaces. IR remote control. Infrared control introduces line-of-sight communication, one of the most widely used remote control technologies. Multimode input control. Control direction and speed using analog joystick inputs. Simple and reliable digital command systems. Control the robot by tilting the controller, translating physical motion into robotic movement. Dual OLED feedback system. With dual OLED displays, students can observe both sides of the communication pipeline, transmission and reception in real time. This enables powerful debugging and deep understanding of system behavior. Learning outcomes. Students working with Car-2 develop wireless communication fundamentals, transmitter-receiver system design, data packet transmission and decoding, communication reliability and latency understanding, multi-input control system design, real-time robotic control systems, integration of radio, Bluetooth, and IR technologies, debugging distributed systems using live feedback. This is where robotics becomes interactive and connected. Multimode control systems. Students master multiple control paradigms. Radio-based control, NRF24L01. Bluetooth-based interfaces. Infrared command systems. Joystick and analog control. Accelerometer-based motion input. Gesture-driven control systems. This builds a deep understanding of how humans interact with machines. Preparing for advanced robotics. Car-2 prepares students for teleoperated robotic systems, remote-controlled industrial machines, human-machine interaction systems, multi-agent robotic communication, distributed robotic systems, plus remote hybrid systems, It builds the communication control intelligence layer required for advanced robotics. The ZAS Navigational Robot Car-2 transforms robotics from autonomous systems into interactive, wireless-controlled machines. With multimode communication, advanced remote interfaces, and a complete transmitter-receiver architecture, students gain real-world experience in how robots receive, process, and execute commands. The UK-engineered design ensures reliability, clarity, and rapid experimentation, enabling learners to master modern communication robotics. Visit our website, explore our GitHub, watch tutorials on YouTube, and take your next step into advanced autonomous robotics, starting today. In this advanced robotics journey, you are not alone. You have the support of the strong ZAS Robotics community. Follow us